events. An independent event is when you replace something, and that means none of the events affect the outcome of the other. Dependent event is without replacement, so the events are related. So the second event is going to have an effect based on how the first event went. Okay, so some examples: flipping a coin 4 times in a row. Well, when you flip a coin, the second time you flip it has nothing to do with the first time you flipped it. So that would be considered an independent event. Choosing a card from a deck and then choosing another without replacing. So if you don't put the first card back in the deck, then your second draw, you're going to have less cards. So that affects the probability of your second event. If you roll a dice 2 times in a row, well, each time you roll the dice doesn't affect the the second time. So these are considered independent events. Choosing 2 volunteers from the class. Well, if you have 30 kids in the class and you choose 1 volunteer, well, the second time you choose, you only have 29 students in the class. So that second probability is affected by what you did the first time. So it's a dependent event. All right, so here's some sample problems. A spinner numbered 1 through 10 is spun 3 times. What is the probability of spinning a 7, then an odd number, and then less than 3? Okay, so the way I like to tell you to do these is think about how many events. I'm going to spin it 3 times. So that is how many events I have. So we want to multiply the probability of each of those 3 events. Okay, so we're going to take the probability of event number 1 times event number 2 times event number 3. So here's our probability formula: the number of favorable outcomes of the event over the total sample space. So for here, if we have a spinner numbered 1 through 10, we've got a total of 10 choices, right? Now let's look at our first event. Spinning a 7 is our first event. That's event 1. Spinning an odd is event 2. Spinning less than a 3 is event 3. So we know we have 10 in our event. So there's only one 7, right? Numbered 1 through 7. There's only one of those. And so 1 over 10 is our probability of spinning a 7. All right, now we want our second event, spinning an odd number. Well, let's think about 1 through 10. We've got 1, 3, 5, 7, and 9. Those are our odd numbers. So there are 5 of them, right? So 5 out of 10 is the probability of spinning an odd number. And then less than 3, a number less than 3. Well, that's only 1 and 2, right? So we have 2 out of 10 probability of spinning a number less than 3. It didn't say equal to. So we're simply going to multiply these together. Multiply your numerator. 1 times 5 times 2 is 10. 10 times 10 times 10 is 1,000. When we divide that, it says give it as a decimal, do not round. So that is going to be 0.01. Here's another example. This time, notice this was an independent event, right? Each time you spin doesn't affect the next spin. This one, we're going to choose 2 green apples without replacement. So this time it's a dependent event. We're not going to replace the apple. So our second event is going to be affected by what we do in the first event. Now it says we have 5 red, 6 green, and 2 yellow apples. What's the probability of randomly choosing 2 green apples without replacement? Write it as a decimal, round to the 100th. Okay, so we've got 2 events. We're going to choose 2 green apples, event 1, event 2. So event 1, we've got a total of 5 plus 6 plus 2. That's our denominator. So we've got a total, so 5 plus 6 plus 2, total of 13. So that's our denominator. Now, we want a green apple. We have 6 green apples, so 6 out of 13. That's probability of choosing 1 green apple. All right, now our second event, we want another green apple. But we didn't put that green apple back. We gave it to somebody or we ate it. So now we have to subtract, right? We only have 12 apples and now we only have 5 green apples. So 5 over 12 is the probability of our second event. When we multiply these, we get 30 over 156. When we divide that, 30 divided by 156, we get 0.19 as our answer in hundredths. So all you have to do in the box is put 0.19. Don't put the work unless it's a constructed response, or else it'll mark it wrong. And then the last one wants to know, what is the probability of getting tails, heads, and heads in that order when flipping a coin? Are these events independent or dependent? Well, we've already kind of talked about flipping a coin, right? We could flip it 100 times and each flip is not going to be based on what you did before. So they're independent events. We've got 3 events, right? We've got event 1, event 2, and event 3. And so what is our probability? Well, with a coin, we only have 2 choices when we flip it, right? We have heads, we have tails. And so tails, getting tails is 1 out of 2, right? Or 1/2. Well, getting heads is the same, right? Because we only have 1 head, so 1 out of 2, 1/2 chance of getting heads, and heads again is same 1/2. So 1 times 1 times 1 is 1, 2 times 2 times 2 is 8. 1 divided by 8 is 0.125 or 12.5%. And it is an independent event. Hope this helps.